Sometimes KiCad doesn't have the symbols that we need. You know, you might be working with an exotic part and you need to create a custom symbol for it. So for this video, we're going to pretend that this symbol does not exist, and also that this very simple dip package footprint doesn't exist either. We're going to pretend that we've come across some part in the wild that we really need to use, and we're going to have to design a custom symbol and footprint for it. Let's get into it. One of the most referenced data sheets in history, the 555 timer data sheet. And what we're looking for is something we can base our symbol off. This pin configuration looks pretty good. It has all our 8 pins. We've got the names and the purposes. So we'll be designing our symbol based off this. Over on KiCad, I'm going to use the Create, Delete, and Edit Symbols button. That opens up the symbol editor, which is where we can see all the existing libraries and symbols. If we try to create a new symbol, we'll see that we need to create it inside a library. So go to New Library, and we'll make this either a global or project library. I would recommend for highly reused parts working in a team, use a global library, and then you can keep all your parts together, maybe git maintain that. For this, I'm going to select a project library. This will be something that's only visible within this project. It's kind of like local and global variables. But I'll just call this my library. Here it is, and now I can create a new part, a new symbol. I'm going to call this symbol the 555 timer. It'll have the default U, which is normal for integrated circuits, and these other defaults are okay. So I'll just click OK. And there's the center of our part. Our part is going to need a symbol body. So I'll first create a rectangle that's hopefully large enough. And I can even select that rectangle, strike E to edit, and fill with the body background color. That's what we're used to seeing in KiCad. Now I need to add some pins. I'll click this Add a Pin button, and we'll just go around the whole device. Ground is pin 1. And for electrical type, I'm actually going to leave these as passive. We can place that ground there, and immediately I know we're going to need a little more space, but we can get to that. Place another pin, and the next one is trigger. I'll just call that trig for pin 2. You can see it's remembered the previous setting, so I can leave that as is. Output is pin 3. Reset is pin 4. And that's actually reset low, so it's actually the not reset. You can see that a negative pulse is used to disable or reset the timer. So yeah, you can be a little bit careful. I mean, strictly, we should call this the not reset. And we can wrap that, we can put a tilde in and then wrap our reset in curly brackets to create that styling. That's pin 4. You could also change the pin graphic style to be inverted, and then that dot means a active low input. So reset with the bubble or reset over bar would be the two styles that imply this is active low. And VCC is pin 8. And I think you can even do that standard subscript styling. Yeah, there you go. So you can even do nice graphical styling like that if you wish, where we have the subscript. Now, we don't have to make this the physical relationship that it is on the package. That is, we don't have to have these pins in the same order. It might actually be more helpful to group these pins in a way that's more friendly for our schematic. For example, you'll frequently see VCC at the top of a symbol. There's a great reason for that, because if we keep that convention, it's very easy to find VCC and ground. The output, we have a bit of a left to right bias in our culture. So maybe we want the output to be in the middle on this side. And then as for the rest, it's a bit of a lucky dip. I might expand this even more. Trigger, discharge. That is as good as any. You could put as much time as you want into making sure everything is laid out nice and even. And there are even KiCad standards that you can look up to reference how these should be made and how these should be named. In any case, I'm going to press Control S to save this. Now I ought to be able to place this part. If I search for my library, I found my library and I found my 555 timer. We can see that there is no footprint associated with it just yet, and we could place this part. We could place our 555 timer. And there's a few differences. For example, the way that I've made it, threshold and trigger are on the same side, whereas over here they're not. So you would have to disentangle the current schematic symbol to connect it to this. I mean, let's do that. So we could delete that, or maybe not delete it. Maybe I will take threshold and connect it to the existing threshold net. Maybe I'd take trigger, and that is also connected to the same net. So actually, we've made a bit of an optimization. We can just connect those two together like that. Reset goes to 5 volts. Ground is on the bottom of the device. VCC is on the top of the device. You get the picture. Control voltage is not connected. Out is connected to the signal. And discharge is connected to this net. So now, hypothetically, we could delete this. We could clean up these extra features, and this ought to work. It ought to be the same. Now I'm actually filming this after I've created the circuit board, so I can go into the PCB design and we could attach the footprint and run the check to see if we haven't violated any rules. But what we first need to do is create that footprint. So to do so, I'm going to create a new footprint. I'm going to create a new empty footprint and call it a dip 8. And it's going to be a through-hole part. Now, we're going to need some pins. Let's have a look at the data sheet. So this is the mechanical drawing of the part. We can see the distance between pins is 0.1 inch or 2.54 millimeters. And the distance between the pins is 7.62 millimeters. And because the pins splay outwards, it can actually be a little bit larger. So this should be really easy to make. We can just place pin 1. And you often see a convention where pin 1 on a through-hole part is rectangular. So we can just make that a rectangular pad. The hole size is 0.762 millimeters. What do we need for this? Yeah, that looks about right. We have a pin here that is 0.38 millimeters. So I think 0.762 is going to be just fine. So pad 1 is going to be rectangular. We can leave that there, but when we create pad 2, make sure the grid is set to 0.1 inch, 2.54 millimeters, and then you can just key down, strike enter, and I'll edit this one to be circular. And now I can just march this pin numbering down. 3, 4, and the convention for for dip package numbering is anti-clockwise from the top left corner. So 1, 2, 3, 4, then I'll go to the right 1, 2, 3 times and put in the rest of the pins. And so that should be 7.62 millimeters across. Yep. And the distance between pins is 2.54 millimeters. So just like that, we have a very bare bones footprint. We can put the reference in, we can bring the metadata in, and we can even draw a box on the silk screen. I'll adjust my grid size, I'll draw a box. What's the package dimensions overall? About 10.2 millimeters by 6.6 millimeters. So on the courtyard, which is basically the keep out area, it's the thing that says this is how big the part is, you could put a courtyard that's a little bit more generous if you wish. But that's a basic part. When we try to save the part, we're alerted that there's no library. I could create a new library and put it just in the project. And we could call this my footprints. Then we can select the row My Footprints, click Save. There's our footprint listing. And then when we go back to the schematic, we can edit just this part, edit the footprint, search for the library, and there's our dip8 package. Could save that. And now when we go back to our schematic, to our PCB layout, when I update the PCB and bring in the new footprint, here's my considerably uglier new footprint, but it should fit and it should be compatible with the existing circuit. I can place that there. I'll move this silk out of the way. Strike B to refill that ground pore. And I don't see any rat's nests. If I run the DRC, that's great. The only warning that we get is for something that's unrelated to do with RV1. But that means that we made a symbol from scratch, we made a footprint from scratch, and we verified that it worked against an existing one because I've just dropped it into a PCB design that has all the traces routed, which means that all the connections are made. We would have had heaps of errors if we'd made a mistake because there would be a trace going to a pad that is not intended. So we got that one-to-one relationship. We don't have any CAD for this part because we've made it from scratch. You could go and link the CAD when you design the footprint. You can just do that from the footprint properties. With these through-hole footprints, we've put the pad on that indicates the direction of the part, but it's probably nice to help out the user as well and put in that dot that people are used to seeing. That would be a helpful feature to have on the circuit board to show where pin 1 is. For now, I've regressed my schematic and my PCB to the built-in part, just so I don't have to put in as much time making it as beautiful as this existing part.